Today we are solving LeetCode 217 containing duplicates in Java. This is a perfect starting point if you want to master array patterns for a technical interview. The problem is simple. We are given an integer array called nums. We need to return true if any value appear at least twice in the array, and return false is every single element is completely unique. Look at the example 1, where the example is basically an array containing number 1, 2, 3 and 1. Because the number 1 shows up at the beginning and at the end, therefore there is a duplicate and we return true. Let's see the brute force. Now we have an array which has 4 elements 1, 2, 3 and 1, just like in example 1. Now how do we solve this? The most straightforward way, the brute force way, is to compare every single number against each other number using a nested loop. We would fix the point I on element 1, and then we would use a second pointer j to scan the rest of the array, checking if any elements equals to 1, meaning we compare 1 with 2, 1 with 3 and 1 to 1. We found a duplicate. In this first example, we found a match quickly. But imagine if the array has 10,000 elements and the duplicates was at the very end. A nested loop means we are checking every pair, giving us a time complexity of O of n square. If you write this in a FAANG interview, it's an immediate rejection because it was too slow. So how do we optimize this to run in O of n time? We trade a little bit of memory space for speed by using an HashSet. An HashSet is a data structure that only stores unique item, and it lets us look up whether an item exists in O of 1, which is constant time. So here is the strategy. We will pass through the array exactly once. For every number we encounter, we will ask the hash set whether have I seen you before. If the answer is yes, we found our duplicate and we can stop. If the answer is no, we throw the number into the set and keep moving. This is our input array. We have our, let's say, our hash set. This is just a hash set collection. Let's name it as HS. So on our first iteration, we will look at 1 and we check whether our hash set has number 1. It is currently an empty hash set, so we add 1 and then we move on to the next element. And check whether 2 is there. Our hash set doesn't have, so we add 2. Similarly, we move on to the next element. Currently it is 3, and we check whether our hash set has. Our hash set doesn't have, so we add number 3 to the hash set, and finally we reach the last element, which is 1. We check whether the hash set has this element. Yeah, it does have. So we ask the set, is 1 already inside? Yes, it is. Boom, we immediately exit and return 1. So this would be our approach to use HashSet. So let's try to code this. So what we want to do is to create HashSet of integers. We will name it as scene, hash set so, and then we want to iterate all the elements in the nums. So we basically use a for loop which basically iterates to the nums. The very first thing that we do is we see whether our hash set contains our num. If it contains, then we are basically returning true. If it is not there, it only means one thing. We just add it to the scene, add the num to the scene because we have seen that number. But If you have run through all the elements, it only means one thing: there are no duplicates. So if there are no duplicates and it contains all unique elements, then we return false. So let's talk about complexity now. The time complexity is a perfect O of n because we only look at each number in the array exactly once. The space is also O of 1 because in the worst case, when every number is unique, our hash set grows to the whole all n elements in memory, and that's it. If you want to practice this pattern and the rest of the blind 75 using interactive active recall flashcards so that the solution actually sticks in your brain for interview day, head over to the link in my description and join our upcoming platform waitlist. Don't forget to like and subscribe, and I will see you in the next video where we can tackle valid anagrams.